it's certainly a pleasure to be here. And I'd like to make some comments on Howard's comment in his opening welcome. He said, looking back on what's been accomplished in systems analysis over the past decades, it seems that there has been less progress than desirable with integrating methodology with real decision making. Why did he say this, and why does he care? And I'll try to provide a few thoughts about that. One key thing, the only way you can purposefully influence anything in life is through decisions. That's it. You can influence it without thinking, perhaps, and acting, but purposefully it's decisions. So decisions are pretty important, and we'll just say it's the decisions the policymakers make that are important for what EASA does. And that's the input, and that's their control. And the output is evaluating all the things that can happen and in terms of human and social well-being and environment. That's the mission of EASA. And in between, there's an awful lot of fog. The relationship is very complex. So what does everybody in this room think that's reasonable to do? I'd say most people think, well, we'd like to have a systems analysis model here, an applied systems analysis model, and have it be thorough. And what do I mean by thorough? Well, it starts right at the beginning with the alternatives, and it goes all the way to the ends to help evaluate those alternatives. And let's take a look at what often happens. This is what we have. We have a typical systems analysis model, and as a result, there are some gaps on the relationship from the inputs to the outputs that we should really be interested in. And certainly the analyses that are done are very relevant, and they address an awful lot of the complexity. And one of the points I think we'll make, and David hit a bit of it in his first one too, is some of the things we miss are perhaps easier to address, and you could get an awful lot of additional positive benefits by addressing them. So what are those gaps? Well, there's a gap at the beginning from the inputs, the alternatives, to what are often used something like scenarios. You can't choose a scenario. Policymakers can't choose a scenario. What they do is choose alternatives, and there's uncertainty about what scenario will occur. And then there's a gap at the end of the model from the indicators that typically scientists choose as the outputs of their models. But those often don't match up with what the policymakers really care about. There's another gap there. And then at the end, so we get the output on a bunch of different metrics or measures that the policymakers do care about, there's uncertainty about what the impacts will be for each of the alternatives on each of those measures. How does a policymaker put that together in their head and think about which alternatives are better than which other ones and why? They can't ask what if questions very much. They can't do sensitivity analysis, what might change things. And so those are the three gaps that are worthwhile addressing. I mentioned the first couple because they're of a certain type, and then the latter one. The policy alternatives to scenarios, well, one of the things you'd like to do is create good alternatives. If you get a whole model, you can help. But also, how do governments, organizations, and individuals act as a result of a policy? How they act is going to influence which scenarios you get. And that would be useful to get there. And traditional systems analysis to relate the alternatives to the scenarios is what you need. Traditional in the sense it models factual things. What will happen or what might happen. That's a factual type of issue versus what's different with the value model. It's what do I like better than what other things. So it's not about preferences, it's about what will be. And therefore, it's a model like we always model. We got these inputs, these outputs, what's the facts, the data that helps us get the relationships and put them together. And then at the end, it's the same thing. We've got some measures that come out that, as I said, typically the scientific team chooses, but then what are the relationships to the ones that the individuals care about? If you have something like let's say a meter of rising water as a result of global warming, clearly that's important. But probably what the decision makers care about a little bit more is certainly what areas of land will be overrun with the water, but how many people will die in the process? How many will lose their place to work, their way to live decently and everything? And those people can move over time, over maybe 50-year period, some of the people. One can model that. That would be useful information for the decision makers. And again, that's a traditional model. So it's just extending out in the front and the back on those two things. Well, the part that's a little different is evaluating those alternatives, because that's a value model. So you're addressing what you would like, not what will be. And what you want to do is address the multiple objectives, the value trade-offs are there, have a way to deal with the uncertainties on what the implications will be, et cetera. And I don't know when it came up again. Oh, I went back, sorry. And so that's the model I'll talk about, the value model. But note that typically for the systems analysis model that deals with facts, the information comes from the harder sciences. With models of the policies that should be chosen, the value models and the actions, the value parts come from the softer sciences, the ones listed there. And they should certainly be used. And what's the definition of a value model from my point of view, and why do you use that term? Well, I think it is basically an objective function. It's how you get it that's kind of important. It's a mathematical representation of your preferences, and you can build them to preferences of individuals or groups. It's tougher with groups, but you could do them. And examples are utility functions or value functions. Why do I call it a value model? Because the process of constructing it is exactly analogous to any of the models we construct. You need to find out what are the variables. That's what are the objectives that the people care about, and how will you measure them? What are the relationships between some of those and overall what you care about? There may be synergies in your values among them, for instance, or there may not be, and I'll mention a little detail on that. You need parameters just to relate them to each other, typically, for instance, weighting the implications of various ranges of impacts on the different objectives, and you need information to specify them. The source of the information is in the heads of decision makers, and you can get this information. It's tough, but that's why you do it. You wouldn't do it if it were trivial, just like you wouldn't build any other model if it were trivial relationships. And so what do you need to do to construct a value model? Put it here in 7 steps. I'll go through the first 3 quickly, and a little bit more time on the first 4 quickly on the latter 3. First, what I do when I talk to anybody, I think, who's a policymaker, I want to get everything in their head that they care about out so we can talk about it in a reasonable way. That's a challenge. It's been shown in some of the behavioral work that Raima has mentioned. People cannot write down all their objectives. I'm one of those too for a tough problem. People have said that forever. And it's hard, but you can induce people to get them out. You can probe, and you just keep pulling everything that's there, and you can do a much better job. That's been shown in their experiments about that. Then you want to state whatever they say they care about, because they don't like to limit how it comes out from them, into an objective, or you can use a verb or a noun, like minimize the cost, maximize the positive contribution to jobs, to the forest industry, minimize environmental degradation, etc. And then you want to look at the relationships among all those objectives, because there will be means-ends relationships. If you have minimize the destruction of forest habitat, That may be what you're fundamentally concerned about, but you may be concerned about how many of different types of species there really. The former is a means to the end. You want to get some of that clarified, and partly because you don't want each of those in the objective function, or you'd be double counting. And then you need ways to measure them. And there are choices. There's no correct answer on how you even choose the measure for anything. So there's subjective judgment that goes into any of these. And I'll spend a little bit more time on the last 3 points there. So how do you get the form of a value model? Here I'll just use a bit of terminology and symbols. Suppose you have a bunch of objectives that are by the capos. The measures, so one objective might be minimize cost. The measures, how would you measure that? That might be measured in millions of euros. A specific level of euros, 300 might mean 300 million euros. And then the consequence that could happen from any policy is represented by a vector, x1 through x sub n, for the n objectives that you have. And then, of course, there's uncertainty about which of those would really happen. And then you want a value model. And the ones I'm typically dealing with are utility functions, because there's uncertainties in the problem that are significant, and utility functions have the nice property that it's appropriate to use the expectation to capture everything you are concerned with concerning preferences there. And so what are the approaches to develop the form of a value model? Well, you use value independence conditions, and that'll imply some, or value dependence conditions. I'll mention the 3 main independence ones, and certainly both David and Ollie independently and now sometimes together have models of preferences where there are dependencies. Some of those are over time, and some of them are within a time period. So you try to use these independence assumptions to break the overall function over n variables down into n functions over 1 variable. Makes it a little easier, where each of those are single attribute utility functions, and the one that's most common, and I think very functional to use, as I'll explain later, is the additive one. And it's where you have, it's a weighted sum of the various different utility functions for the objectives. And the weights are not an answer to the question, how important is this objective versus that objective? And I mention that because it's overwhelmingly the biggest error ever in these things, because that question doesn't make any sense. Because it's how much of a change on each dimension that has importance, not its name. Is cost more important than safety in your life? Most people might, no, safety is a lot more important. Well, are you willing to spend 200,000 euros in order to get a micro enhancement of your safety? Probably not, if they're your own euros. So what does it mean? You got to talk about how much safety and how much cost. So that's the way the case gets assessed at the end. And you get those from decision makers by asking them questions. Now, you don't go just ask, one time a few questions and then you put it together. You want to converge, you want to do consistency checks, and every executive I've ever assessed their preferences, I start out and say, you will certainly give me inconsistencies. And that's not a problem. It's that preferences are very complex. And so by having those inconsistencies shown, we'll be able to talk about them and iron many of them out. Recognize them and then talk about them and iron them out. That's part of the purpose in doing the assessment. And then you'll eventually use the model, trying it out on simple alternatives to see if it gives you outputs that you can see represent what you really think, and you build up what you think is appropriate for the model and get it so that it's not the weak part of the overall analysis in any sense. Because the factual model, the traditional systems analysis model, is so much more complex. So the independence concepts, and I'll go through these very quickly. One is preferential independence, and you need 3 dimensions here. It's simple. X, Y, and Z representing the measures for 3 objectives. And let's look at the relative preferences between x and y, holding z fixed. And so you look at the bottom level of the figure here, and that's a set of iso preference curves over x and y with that lower level of z. If you get the same iso preference curves for different levels of z as long as it's fixed, that's preferential independence. Utility independence, since it's the same type of notion, you only need 2 dimensions. We can fix the level y and look at the one-dimensional conditional utility function over x, and if it's the same for any level of y, that's called utility independence. And the additive independence looks at your preferences over combinations of things, and you need 2 dimensions. So suppose you had 2 lotteries, L1 and L2, which are just 50-50 chances of the corresponding 2 consequences there. If you look at L1, there's a half chance of getting level x and level x prime. And it's the same for lottery 2, a half chance of getting x or x prime. And the same will happen for the y's as you can look at it. So it happened, if you're indifferent between those 2 lotteries, it means your preferences don't care how they're put together. And that's going to lead to an additive utility function, why it's called additive independence. And 2 slides show some of the results of the forms of the models here. If you get additive independence, you get the additive utility function that everybody knows about there. A weight on the first objective, or first utility function times it, plus a weight on the second times it, and the scaling's indicated there. Now, if each x and y for a 2 objective problem are utility independent, but that's all you have, you get the next function there, where you'd see the first 2 terms are in a traditional additive utility function, and then there's plus another constant, k sub xy, times the product of the utility for x times the utility for y. Is that additive? Well, come to that in a moment. You can assess those. But just to show an example for n dimensions, the same type of thing, if you have the first dimension x1, or any one, but x1, paired with each of the other measures, and if they are preferential independence of the remaining ones, it's pairs, and if one of the objectives is utility independent, you get an additive or a multiplicative form. Same ones Ollie talked about in spirit there. So let's go to practical value models. The first line there about CT is an additive model. The next one is the one that, is it additive? Well, it's something plus something plus something. That's pretty additive. And the key is, what's that third term representing? Because the first one deals with C, which is cost here, if it's an example of cost with travel. And then T, the time of your travel, is the second term. What's the third one? Well, in this type of situation, it could be, if you recognize that got to represent something other than time and cost, kind of fairness or something, because you don't want a combination of paying the most and taking the longest to get there. You're willing, it's okay to pay the most and get there quickly, or pay the least and get there slowly, which would be in the other one. So you do care how they're put together. And what you want to get is only the fundamental objectives, and then that should be an additive function. In other words, you want to get rid of all the means that lead you up to what are called the fundamental objectives. And then I'd just like to very quickly mention 4 studies. David mentioned the spruce budworm that was done here at IASA in the beginning. Another one was who can fish where, when, and how on the Skeena River in British Columbia for salmon. The decision maker was the Department of the Environment of Canada, and there were various stakeholders there. Their values were included in this problem. Stakeholders were commercial fishermen, 2 types, lure and net fishermen. Upstream from them, they had sport fishermen, and then the regional development in some of these areas, all the jobs, you know, from the hotels that support the sports fishermen and everything, are based on that. And then upstream from them are the First Nations people of Canada, and they all have different concerns and then the Department of Environment of Canada has their preferences for putting them together. This was work with Ray Hilburn and Carl Walters. Tisa River Basin in Hungary. Different plans to develop the water resources there, one of the two big rivers that comes into Hungary. And this was work done with the Hungarian National Water Resources Authority and with Eric Wood. And the last example, one by Detloff a little later, with policy for oil discharge into North Sea from offshore oil platforms, where he had different stakeholders there and found a lot of alternatives that were dominated by others. And two last slides. What could be done? Well, working with policymakers and stakeholders that they care about to find out why they care about the decisions they're addressing, what alternatives they have, is crucial. I mean, because they make the decisions, and if you're not talking to them, that's tough. And so a group doing traditional systems analysis could have a few people who have some skills, like one in a group, who can work on this and really get into the heads of some of the decision makers. And what's the benefits, and why does Howard care? Because the effort required to build a value model is a lot less relative to the traditional systems model. If 1% of the effort were used, it would be massive. Including policymakers in this way makes them much more interested in the study, because you're modeling what they care about. And you can build up the trust and the collegiality with them so they are really interested. And therefore, you can provide much better insights to them because you're addressing what they care about, and you're going to have a lot more influence on what they do, including you can then go forward with alternatives that they didn't even think of that you have from your analysis to suggest might be better things to consider. And thank you.
Thank you, Ralph.